Good morning everyone. Today we are going to study the couple analysis, structural and thermal. So in that one problem is there. So this problem axial load of 400 kilonewton is applied at 20 degrees Celsius. Input temperature is 20 degrees Celsius and thermal temperature is then raised to the 50 degrees Celsius. The material of the for the elements is aluminium and for second element is a steel. So both properties of the element 1 and 2 is given. Material aluminium for the first element and for the second element material is steel. Modulus of elasticity is 17 to 10 raised to 9 Newton per meter square. So we can convert it into 17 to 10 raised to 3 Newton per mm square. For the steel 200 into 10 raised to 9, which is to be converted into Newton per mm square is 200 into 10 raised to 3 Newton per mm square. Cross section area is given 900 mm square, 1200 mm square is for the element number second. So length of the member 1 and 2 is given. According to that you have to draw the structure. Coefficient of thermal expansion also given 2.3 into 10 raised to minus 6 per degree Celsius, and for element 2 coefficient of thermal expansion means alpha is given 11.7 into 10 raised to minus 6 per degree Celsius. So we have to determine the element stiffness matrix, load vector, nodal displacement and stresses in each member. So while calculating this we need to go for the Anlaysis software. In this Anlaysis software we are going to solve the problem. So and check the results with these theoretical results. So while checking these results we have to solve this problem with the help of these models. This is a fixed support and this is also one of the fixed support, and for the first point this is a 0 0 coordinate system. Then for this second node point it is a 200, 0, and this is for third node points 500, 0. So according to that we have to set up the system. First we have to go to the 2D static problem. This is a 2D static problem and this is a thermal problem. That's why we have to solve the couple problems, okay, structural as well as thermal problems. So first node point is 0 0 0, add that point. Then second one you can see that this 200 0 0, 200 0 0, add. Then 500 0 0, add. So when we will get the 3 points, you can give the name for node numbers for these 3 points 1 2 3. Now I want to join these elements. So by connecting 1 and 2 we can connect the beam 1 comma 2 enter, 2 comma 3 enter. So you will get the 2 elements. After that go to the XY view. So you can see the XY view. So this is the first element, second element, and first node, second node and third node. According to this image we need to calculate, we have to apply the material and boundary condition to this element, first element, as well as for the second element. So while applying the material properties, means aluminium material, so we have to apply Young's modulus. So like that for these two materials, two elements, two different materials, cross section area and thermal expansion coefficient, we need to go to the Lisa again. And in this Lisa first we have to select the edit by node number, select by node number, and through this node number you just have to add the elements, add elements, and in this add elements you need to assign a new material. Now here for the first member which material we have to add? We have to add the aluminium. So whatever the properties of aluminium, this is cross section area, so need to calculate the cross section area. Through this cross section area we need to calculate the whatever the there, we need to calculate the diameter of the bar. So for that, for diameter of the bar, first 900 into 4, pi by 4 d square is equal to area. So 900 into 4 divided by 3.14 and take a under root of this, so you will get the 34 is the diameter of this bar, diameter of this bar. So you have to write here 34. Then mechanical properties, go to the isotropic property. Here you need to assign a Young's modulus, that is plus 3, 70 10 raised to 3 Newton per mm square. Poisson's ratio is 0.3. Density, if you know, you can write thermal expansion coefficient is given 2.3 into 10 raised to minus 6. 2.3 into 10 raised to minus 6. So assign all these properties and close the window. Again go to the second element and add the elements. In this second elements you need to assign a new material, circular bar, and again you have to calculate the what is the diameter of the second bar. That is a 1200 mm. So 1200 into 4 divided by 3.14. So you will get, and take under root of this, 39 is the diameter of this bar. So write down there 39. Go to the mechanical properties, isotropic properties. Here you just write the Young's modulus. What is the Young's modulus for second element? 200, 10 raised to 3. Why 3? This is a Newton per mm square. Okay, and the Poisson's ratio we need to apply 0.3, and thermal expansion coefficient is 11.7 into 10 raised to minus 6. 11.7 e raised to minus 6. So close the tab. So right now we have given the material property to both the elements. Now we need to assign a fixed supports. So where is a fixed support? For the first node and third node, and the second node there are 400 kilonewton force which is directed towards the positive x-axis. So like this you need to select the first fixed support. This is also fixed support. Select the faces, go to the load and fixed support, and OK. So you will be fixing the first and third node. Now for the second node I want to apply a force which is directed towards the positive x-axis. So new force, and which is directed toward positive x-axis. So which is a 400 E3 means 400,000. Okay, so in this it is directed to this. Now this is a couple problem. Couple means the thermal plus structural member is there. Therefore here we want to apply for all elements. Select all elements and select all elements, and right click here, and through this write the new temperature. So this is your initial temperature, means whatever the temperature you are assigning, this is your final temperature. Okay, so what is the final temperature in this problem? In this problem final temperature is 50 degrees Celsius, which is raised to 50 degrees Celsius. So 50 degrees Celsius. Okay, and then again go to the select element and select all the elements and right click, and through this new thermal stresses, here you have to write a input temperature. What is the input temperature? That is a 20 degrees. सुरुवातीला किती होतं? 20 degrees Celsius. So write down 20 degrees Celsius. Okay, and then solve this problem, and after solving you will get the result. So displacement at this member. Okay, so in this table you just double click over that and select all, and select displacement and longitudinal stresses 1, and OK, click OK. So through this table you can find out what is your results. Okay, so first we can see these results. I have a screenshot of results. You can see that what is the displacement here. Here you can compare these results. For the first node point displacement is 0. For the second node point displacement is 0.287. So just see that in this also 0.287 mm. Okay, displacement, and displacement as first and second is 0, 0. First and third node point is 0. In second point that is 0.287. Okay, and whatever the stresses at element, so go to the element value and see the stresses at element. So 95.85 Newton, okay, per mm square is the stresses at first element. 95.62 Newton per mm square. Okay, and at a second right now I have not taken the picture, but So whatever the minus 261.98 is at a second. Okay, and you need to calculate the reaction at first node point and third node point. Okay, so this reaction you can calculate by using here is a one tab reaction, so you can see that reactions. So 86 here, 87 is there, and 31 here, 31.38, 31.29. Okay, so total overalls you can calculate it. So it is minus 400,000, means 400 kilonewton. So it is coming. Okay, here also it is coming. So this is a reaction forces. Thank you for watching this video. Please like and subscribe to my YouTube channel. So this is a couple analysis for structural as well as